we are asked if f and h are inverses of each other. Are they inverses of each other? Where f of x is the cube root of 9x plus 4, and h of x is equal to the rational expression x cubed minus 4 over 9. Well, if something is an inverse, then when we compose it with the other one, the output's x, and vice versa. If we switch the order and compose it in the other direction, then the output also has to be x. If that's true, then they are inverses of each other. So we would look at, it doesn't really matter which one we start first, this one's first. So I take my f function, I stick x in it, and then I want to know, question mark, does that equal x? And then the other one, going the other way, if I reverse the composition, does that equal x? So that's a question mark. So we have to compose each one of these, simplify it all the way down, and see if we're left with just x. So this is very much an algebra exercise. So here's my f function on the outside, h. I'm just replacing it with x cubed minus 4 over 9. Now this is a great example of where I use my skeleton idea, because we're plugging in a function, so a lot of times students, they get confused when you're plugging into a function. So let's see if I can't simplify it. The f function is this one right here. So wherever I see an x, I just put parentheses. So this is the cube root, nice and big, 9, there's my x, big parentheses, plus 4. So here's my skeleton. This is the f function. This is exactly the f function, but instead of x, I have parentheses. Now, I hope you can see how easy it is just to plug in that function. X cubed minus 4 over 9. And we're trying to simplify here. Okay, well, I need to simplify all of this out. It looks like I take care of what's in the inside first. So this is equal to, I still have the cube root over everything. This is a denominator of 9, this is a multiplier of 9, so it's like they cancel. Remember, that's like 9 over 1, so it's a 9 on top here, and the 9's cancel. So I'm left with x cubed minus 4 plus 4, and then these reduce out, and it equals the cube root of x cubed. Those are inverse operations of each other, and we are left with just x. So this one is okay. Then I have to check on the other side. So notice when it's f composed of h, it's equal to x, so we're good there. I just have to make sure if one of these sides don't work, we can pretty much stop if you're sure of your math. But oftentimes if one side doesn't work, I just look over my work real quick to make sure I haven't made a careless error. All right, so now we have the h function. Inside of h goes the f function, which is cube root of 9x plus 4. All right, once again, here's my skeleton. So the h function is this right here. Whenever I see an x, I just put parentheses. So it's going to be parenthesis, that's the x, then all that gets cubed. There's a minus 4, and then a divide by 9. And then I just kind of check, does that look like this one right here, except for where there's an x, I have parentheses, and yes it does. And then, once again, it makes it a lot easier to take your function that you're plugging in and just stick it right inside wherever you see parentheses. So inside this parenthesis goes the cube root of 9x plus 4. Okay, let's go ahead and start simplifying. These are inverse operations of each other. Cube root, those undo themselves, and we're just left with what's inside here. And it's 9x plus 4 minus 4 divided by 9. We do these order of operations. The top is done separate from the bottom. So I simplify the top. 4 minus 4 are opposites of each other. They go away. I'm left with 9x over 9. And we have a common factor here. The 9's reduce out, and we're left with x. So that is a check. That is a check. So both of these are equal to x. That means they are inverses of each other. So are F and H inverses of each other? Don't forget to answer the question. So you've done all the work, and the answer is yes. They are inverses of each other.